morning to all of you students. Today I am going to teach you the fundamental theorem of integral calculus for complex function. So this theorem states that let f of z be a single valued analytic function in a simple connected domain D, or we can say in a region R. So if AB belongs to this domain D, then we have to show that integral from limits a to b f of z dz, this is equal to phi of b minus phi of a. So for this and where phi z is an indefinite integral of this function, that is f of z. So what we will do here, so we will take, let capital F of z, this is equal to the integral a to b f of t dt. So name it as equation first. So then the indefinite integral phi z, so then the indefinite integral phi z of this function f of z is given by phi of z, this is basically equal to this function f of z plus some constant, so f of z plus c. So now from this we can also write what is phi of a. Then phi of a is basically f of a plus c, and similarly phi of b means the value of this function at a and the value of this function at b, this will be f of b plus c. So what is the difference of these two functions? That is phi of a, or we can say phi of basically we have to find the difference of phi of b minus phi of a. So I will write here, so phi of b minus phi of a, this is basically equal to, this is equal to f of b plus c, then minus f of a plus minus c, then c gets cancelled and we are left with f of b minus f of a. So name it as equation number 2. So we can write from equation first, we have, so what was our first equation? That was f of z, this is equal to integral a to b f of t then dt. This was our first equation. So from this equation, what will be the f of b? So f of b is basically the limits, that is I am taking from z naught to b, then f of t dt. And similarly f of a, this will be equal to the limits z naught to a, then f of t into dt. So now I will take the difference of these two terms, that is f of b minus f of a, this is basically equal to integration from z naught to b, then f of t dt, then minus the limit z naught to a, then f of t dt. So basically our limit was from a to b, so I have basically divided this limit in two parts, that is first term from I can say from z naught to b, and the term is that z naught to a. So now from this we get z naught to b f of t dt. So if we have to change the limits, then here it will be the minus times, so this minus, and after changing the limits we get one more subtraction sign, so this will become positive term, and this will be now a to z naught, then f of t dt. So this is basically the integral a to b, now f of t dt. So from this we can say that, or I can write here from equation second, so basically equation second was f of b minus f of a, this is equal to phi of b minus phi of a. So instead of this I will write here, I will use this equation in this equation, that is name it as equation third. So f of b minus f of a. So using second in third we get phi of b minus phi of a. So this is equal to integral a to b f of t dt. So, or we can say that phi of b minus phi of a, this is equal to a to b, then f of z into dz. Hence proved. Thank you.